Today we'll take a look at solving fractional equations. This stuff does tend to make its way onto the Regents exam each year, so good thing to be able to do. All right, and just like most of the lessons in this unit, we're dealing with, multiplying, least common denominators, cleaning things up, making them more doable. Okay. Equations involving fractions or rational expressions arrive frequently in mathematics. The key to working with them is to manipulate the equation, typically by multiplying both sides of it by some quantity, so that the fractional nature of the equation is eliminated. Basically, let's get rid of the fractions and give ourselves something easier to work with. The most common form of this practice is called cross multiplying. So in the first example, we'll see some cross multiplying problems here where we take the top of one fraction, multiply by the bottom of the other fraction, and we can set the two sides equal. So in part A here, 4x plus 5 over 2 equals x minus 1 over 5. So I'm going to multiply, again, cross multiplying, we're multiplying these things together, okay? So I'm going to write like this, 5 times 4x plus 5 equals 2 times x minus 1. Okay, let's distribute. And we have a linear equation now in terms of x. I'll get all the x's on the left, everything else on the right. So subtracting the 2x and subtracting the 25, and we're looking at 18x equals negative 27, and divide by 18. And we can simplify that. Both are divisible by 9. That's negative 3 halves. Okay, so we cross-multiplied, distributed, and solved. Okay, similarly for part B, let's take a look at this. Again, let's set up with parentheses to do the cross multiplication. And on the left, we'll be careful, double distribution here, or FOIL. We're going to end up with x squared. We're going to have a plus x and a minus 6x, so minus 5x and a minus 6, and 4 minus 2x. Okay, so this time we have a quadratic equation. We'll set it equal to 0 and solve. So adding the 2x, we're going to get a negative 3x. Subtracting the 4, we're going to get a negative 10. So this should factor. Looks like x minus 5 times x plus 2. And we get x equals 5 or negative 2. Now, we do want to again check to make sure we don't get any zeros in our denominator with these values. Positive 2 would make that 0. Positive 6 would make that 0. So we didn't get either of those numbers. Both of our answers are okay. All right. So again, if you have basically to cross multiply, you have one fraction on one side equal to one fraction on the other. If you have any sort of addition of fractions or things that are more complicated than that, you're not going to be able to cross multiply, as we see in the coming examples now. Since this technique should be familiar to students at this point, we will move on to a less familiar model when more than two fractions are involved. The next exercise will illustrate the process. So here's what I'm talking about. We've got, more than just one fraction equal to one fraction. We've got the subtraction of two fractions on the left equal to a fraction on the right. Consider the equation. 1/2 minus 9 over 4x equals 3 over 4x, and we want to solve for x. What is the least common denominator of these three fractions? Well, the smallest thing 2 and 4 both go into is 4 itself, but we also have that x to deal with. So 4x is going to be our least common denominator here. Part B, multiply both sides of this equation by the least common denominator to clear the equation of the denominators. All right, so let's see what happens if we multiply both sides by 4x. So again, these get distributed to the numerators. Well, let's see. When I distribute a 4x to the 1, I get 4x. Divided by the 2 below it is 2x. 4x distributed to the 9 is 36x. Divided by the 4x below it just takes us back to the minus 9. Basically, the 4x is canceled. And on the right-hand side of the equation, the same idea. The 4x's are going to cancel, just leaving us with the 3. Or if you do it out, you get 12x over 4x, which again is just 3. Okay, so that's the whole idea here, is we're going to multiply both sides by the least common denominator, distribute to the numerators of our fractions, clean them up a little bit, and then we'll have something we can solve. Okay, so we get this linear equation. We could add the 9, and we end up with x equals 6 here, which again, looking back at the original denominators, That's an okay value. It doesn't result in a 0 in the denominator. Okay, so here we get x equals 6. It is very important to note the similarities and differences between this technique and the one employed to simplify complex fractions. With complex fractions, we multiplied by 1, the number 1, in creative ways. We found the least common multiple, but we multiplied it on top and bottom of the major fraction. Whereas in this situation, we're actually multiplying both sides of the fraction by the least common multiple. So that's the big difference. To solve, we multiply both sides of the equation by the least common multiple. And to clean things up, we basically multiply by 1 over 1. Okay, so today it's all about multiplying both sides of the equation. Let's take a look at number 3. Which of the following values of x solves this equation? Okay, so looking at my denominators, there's no x's. Looks like the smallest number, 6, 10, and 15, all go into is 30. So our least common denominator here is 30. So I'm going to multiply both sides by 30. And let's see what happens here. So distributing. So watch how I do this, okay? Basically, I'm not going to write 30x minus 120 all over 6. I want to kind of simplify as I go. So I'm actually going to do the division part first. Think about this. What's 30 divided by 6? That's 5. So we have 5 times that x minus 4 in the numerator. Distributing the 30 to the second term. 30 divided by 10 is 3 times the x minus 2 that's still in the numerator. On the other side of the equation, what's 30 divided by 15? Oh, that's 2 times the 31 that's left in the numerator. So I tend to try to simplify these as I go and make the numbers smaller as opposed to larger. So I just kind of clean it up as I go, and now business as usual, a little bit of distribution and solving of the linear equation. So let's see what we get here. 5x minus 20 plus 3x minus 6 equals 62. All right, 5x and 3x is 8x. Negative 20 minus 6 is negative 26. We'll add the 26 to both sides. And that gives us 88, so it looks like dividing x is going to be 11 here, choice 4. Okay. All right, moving on. These equations can involve quadratic as well as root expressions. The key, though, remains the same, multiplying both sides of the equation by the same quantity. Again, the least common denominator. Solve each of the following for all values of x. Okay, in part A, again, we've got a lot more than one fraction equal to one fraction, so no cross multiplying. Multiply it by the least common denominator. So I'm certainly going to have an x squared as part of that. And it looks like the smallest number, 5 and 10, go into are 10. So let's see what happens if we multiply both sides by 10x squared. Okay, so again, I'm going to do it in terms of division. 10x squared divided by 10 is x squared. 10x squared divided by x is 10x times the 1 on top, so just negative 10x. 10x squared divided by 5x is 2x times the 1 on top is 2x. 10x squared divided by x squared is 10 times the 2 on top is 20. Okay, so rewind and take a look at how we did that. And now we recognize, once you get it, plus play, and now we recognize we've got a quadratic equation, so let's set it equal to 0. Subtracting the 2x and adding the 20, we are looking at x squared minus 12x plus 20 equal to 0. So I want numbers that multiply to 20 and add to negative 12. Let's see. Do such numbers exist? Let's see, not 6 and 4, or excuse me, not 5 and 4. 10 and 2, of course, right? And let's see, we're going to have x minus 10, x minus 2. So here we get two values, x is positive 10 or positive 2. Again, looking at the original denominators, the only value of x that we would reject here would be 0. Neither of our values are 0, so we're good to keep both of these. Okay, looking at part B. Okay, so the smallest number, 2 and 4 go into is 4, and again we have an x squared. highest power of x is always going to be part of that least common denominator. Okay, so on the left, 4x squared divided by 2 is 2x squared times the one on top is 2x squared. 4x squared divided by x is 4x times the 3 above it is 12x. 4x squared divided by x squared is 4 times the negative 1 is negative 4. So that's what we should get on the left. On the right, 4x squared divided by 4x is x times 1 on top is x. 4x squared divided by 2x squared is 2 times the 1 on top is 2. So here we get this quadratic. I'll subtract the x and I'll subtract the 2 to set it equal to 0. Okay, I don't think this, well, look, we got a leading coefficient greater than 1, so this may factor here. So take a moment. And I think we're looking at 2x minus 1 and x plus 6. Okay, that should give us the plus 12x minus 1x is 11x in the middle. Okay, so here we set each piece equal to 1, and we're going to get x equals positive a half or negative 6. Excuse me, and again, neither of those values give me 0 in my original denominators, so they're both good to go. Okay. So again, you know, it's similar to what we saw in other lessons in this unit. We get linear and quadratic equations back after we do a little bit of manipulation of the original thing. And there you go. Okay, and down below, last couple examples here. I think they look worse than they are. Because fractional equations often involve denominators containing variables, it is important that we check to see if any solutions to the equation make it undefined. That's what we've been talking about in the previous problems when I say, oh, we don't get 0 in the denominator, we're good. These represent further examples of extraneous roots. So that means we reject any value we get for x when we solve these that would have given us a 0 in our original denominator. So in number 5, look, it looks worse than it is. Again, it's like what we saw with complex fractions, multiplying and adding and simplifying in general. If you can factor it, the denominator, factor it. So in part A, x plus 1 over x plus 5 plus 18 over x squared plus 8x plus 15 equals 9 over x plus 3. So the middle term, 18 over, that's something we can factor, okay? And what you'll typically find, let's take a look at these factors, all right? So I'm going to rewrite this. So what multiplies to 15 and adds to 8? Well, of course, 5 and 3. And what do you notice? Those are exactly the factors we have in the other two fractions. So typically, if there's something to factor, it typically is going to be set up in this way that the factors of what we have here are going to match the other ones. Okay. So the least common multiple in this case is the product of the quantity x plus 5 and x plus 3. So, you know, a little more involved in that respect, but it's really the same idea of what we've been doing here. Let's talk about what happens when we distribute this stuff, okay? When I distribute the x plus 5 and x plus 3 to the first quantity, the x plus 5s are going to cancel, right? They're the same. They're going to cancel, and we're going to be left with the x plus 3 times the x plus 1 that's up in that numerator. Now, when we distribute to the next term, the x plus 5 and x plus 3, that completely cancels away. And that just leaves us with the 18 that's up in the numerator. And on the right-hand side, when I distribute to the 9 over x plus 3, it's the x plus 3s that are going to cancel, and we're going to be left with that 9 in the numerator times the x plus 5. Okay, so this is typically how I work these out. I try to clean up as I go. And now, like before, we'll multiply these things out, solve the quadratic. So here we're going to get x squared plus x and 3x is 4x plus 3 and 9x plus 45 when we distribute. Once again, we get a quadratic. I'll set it equal to 0. Subtracting 9x will give us a negative 5x. And let's see, 3 and 18 is what, 21? And 21 minus the 45 will be negative 24. Again, take your time, go slow with that stuff. And let's see, are we able to factor? I think so. Minus 8 plus 3. So here we're going to get two values. We're going to get x equals positive 8, and we're going to get x equals negative 3. But look at the original denominators, okay? If I got back, let's see, a negative 5, that would give me a 0 in one of these. If I got back a negative 3, that's going to give me a 0 in one of my denominators. So we're going to reject that, okay? X equals negative 3 does give us a 0 in one of our original denominators. So we're going to reject that, and here we only accept x equals 8. Okay, and last up, very similar type of problem here. I will, again, notice we have a rational equation, fractions with x's and an equal sign. We're going to factor that denominator, and if you take a moment to do it, you won't be surprised that you do indeed get back x plus 6 and x minus 2. Exactly what we have in the other fractions. Okay, so this time we're going to multiply through by the product x plus 6 and x minus 2. When I distribute to the 4, both the x plus 6 and x minus 2's cancel. We're just left with that 4 in the numerator. When I distribute to the next term, x plus 6's are going to cancel. We're going to be left with the x minus 2 and the x minus 1 that was in the numerator. On the other side of the equation, when we distribute, the x minus 2's are going to cancel, and we're left with the 1 times the x plus 6. Okay, so again, we'll carefully FOIL, distribute, and solve. So here we get 4 plus x squared minus x minus 2x minus 3x plus 2 equals x plus 6. I'm going to rearrange terms, clean this up a little bit. Okay, and setting it equal to 0, we get x squared. We're going to subtract x. We're going to subtract 6, so the 6's will go. And we get x times x minus 4, which gives us x is 0, x is 4. If one of those makes the denominator 0, then we got to reject it. Let's see. Here, x equals 0 is okay. It doesn't make any of our denominators 0. X equals negative 6 would make a denominator 0. X equals positive 2 makes a denominator 0. Okay, so both of our answers are good here. We didn't get any of those back. Okay, so sometimes you end up rejecting, sometimes you don't. Really all comes down to the problem. All right, folks, homework solutions are done out, so give them a try. And then you can look through, come back and look through the solutions here and pause as you need to. Okay, number 3, you get some imaginary complex numbers back. Watch out for that stuff. Okay, number 4, a little tricky. Have a good day.